have. All right, if we kind of look upwards, or if we look at like if there's not enough herbivores, then the carnivores that eat them are going to starve and die, and their populations will have to decrease. So if herbivores are dying, eventually the carnivores are going to go with them. And there are some theories that that's what happened with the dinosaurs, actually. So there's different theories, but this one makes sense to me. So we talked about how in Unit 4, the dinosaurs went extinct from this asteroid impact, blasting a bunch of material up into the sky, a bunch of smoke, ash, volcanoes erupted all around the world, we think, that shot all this stuff into the atmosphere, creating this sort of blanket around the Earth that blocked the sun, which causes temperatures to drop, which was a problem for the dinosaurs. But also we think there was maybe less photosynthesis because the sun was being blocked and the plants were dying. So that was then going to cause the herbivores to not get enough food, which is what we have here, and they start dying. And so some theories say that this is what happened, that the herbivore dinosaurs, like this one and these type, were dying first because the plants weren't growing as much, and then the carnivore dinosaurs, like T-Rexes and stuff, like maybe what we have over here, they started dying next and later. And there's no way to totally know, but that theory certainly makes sense, and it would have fallen into the too few herbivores, resulting in the carnivore dinosaurs starving and dying off maybe last in that extinction that happened. Alright, last one for this little video, because I don't want to make the videos too long, because it kind of got messed up on another one, so I got to make sure they're less than 15 minutes to upload them easily. But anyways, so we'll finish with this one, and then I'll start another video. So the predator-prey relationship we'll go into here in a second. It's pretty easy to visualize. And we're going to talk about wolves, which we see here, and there's some back here, and moose, because wolves hunt moose. And what we see is there's many more wolves than moose. So if the food is really big on a numbers pyramid, which we talked about in the notes, or in the 5.3 notes, if an organism is really big in a numbers pyramid, it can provide for more. So we could have one moose providing for 10 wolves, but that's only if the food source is really big. So anyway, so on the next page we're going to look at a graph that deals with the predator-prey relationship. So they fluctuate together. And it's pretty easy to visualize. Like, think about this on a graph as I go over this. So let's say we have a certain number of prey animals like the wolf. Like the moose. And if suddenly the predators start reproducing a lot, let's say, there's going to be too many, and they're going to eat up all the prey. Okay, so imagine this on a graph. Predators go up, prey goes down. So it makes sense, right? They're eating up all the animals, the prey animals. Then, because there's less prey animals, the predators on a graph would start to go down because they're starving and dying, and their populations decrease. And now there's less predators, so the prey start to increase again, so they'd be going up on the graph, and that's followed by an increase in predators, and so on and so on. So they, as one goes down, the other goes up, and they kind of like fluctuate together. But if the prey goes down, the predators go down with them until the prey can recover. And we see that here in this graph. So this was a study of wolf and moose populations, looks like on Royal Island or Isle Royale, that was done in the mid-90s, and it at least was finished then. And it actually, if we were in class, I have diagrams, as you guys know, that I give out with the notes, and it actually goes a little farther. It actually comes like into 2000. So I'll explain what happens next that we can't see on this graph. But so what we have here is the moose is the one with the circles, and the wolves are the solid line. So let's follow what happens here. So let's focus on the predator as we start. So what we see is we see a decrease in the wolves right here. And it was because the moose population was pretty low. And so they were there wasn't that many. Actually, if you look over here, there's only like 12 in like 1950, whatever, 7 or whatever this is. There was only 12 moose. But if we look over here, oh, sorry, I got it backwards. There were like 500 moose providing food for 20 wolves. There we go, I got it backwards. So, again, you tend to need more prey animals than predators. So what we see is the wolf kind of increased, but then it started dropping. And when the wolf dropped, the moose went up. So there was less predators, so now the prey can increase. And then we see, boom, the wolf also increases. And we see these crisscrossings which are kind of like important transitions. So as the moose went up, the wolf directly followed it. And then something interesting happens here, which I sometimes bring up in class and see who can figure it out. We see this drop in the wolf, which makes sense because it's following the drop now of the moose. So the predator just went up, so the moose starts to go down, and eventually the wolf is going to go down. But what's weird here is we see him shoot back up. So sometimes I ask questions in class about this, so maybe think for a second, like, why might it have shot up even though the moose is declining? And maybe some of you are coming up with an idea. And the thing that makes sense to me is they found another food source. Maybe there was some other animal they started wiping out and killing and eating, because their population this is the highest it ever reaches. There's 50, and back down here there was 20 wolves. So that's they've increased a lot. And then boom, we see this collapse. Okay, and that's like 40 wolves died or something, which is 80% or whatever. Maybe 75 to 80% of their population like collapsed. So whatever they were eating here instead of moose probably also ran out, and then bam. And then what do we see? The moose starts to recover. So now there's less predators, the moose is recovering, the wolf is kind of stabilizing, and then if we were in class, I'd say, okay, what do you think happens next? And I bet you guys understand, now there's so many moose, looks like there's like almost 2,500 moose, right? Lots of food for 15 wolves. On the graph I actually hand out in class, if I had it, or I don't have it on the slideshow, the wolf starts to go up, and then you already guessed the moose starts to go down. And in the one that I give out, they haven't crisscrossed yet, but it's basically assumed that they did crisscross, and they just kind of keep going through this process, and that's called the predator-prey relationship. And this is how they balance together. And this is part of in some of the notes you've had already. You see me emphasizing the word balance or stability, and this is a special form of balance between predators and prey called the predator-prey relationship, where they kind of exist together, and that would be a type of coevolution, and coevolution was part of Unit 4. All right, so I'm going to stop it there, and we'll continue on the next one.